Yeah. So, hi guys, and hope everyone is doing well and staying safe. So, I welcome you all to the very first episode of the AWS webinar series done by the T and Tech Innovative in collaboration with the AWS Focus Group at 99X. So, if you are into AWS Serverless, uh, and want to be a hero from zero, this webinar series is going to help you out in a massive way. So this webinar series contains of 4 sessions, and the main topics that will be covered are introduction to serverless computing, which will be happening today. And then in the upcoming sessions will be on AWS compute services, data store services, and finally there'll be a session on application integration services. So these sessions come with practical demos where you can do hands-on sessions with the speaker and ask about anything if you get stuck at any point as well. So yeah, in today's session, we'll be talking about the basics of serverless computing and some use cases, as well as some sample architectures of AWS serverless. So thank you all for joining with us. And if you have any questions, you can drop it on the YouTube chat and they will be answered during the Q&A session at the end. So yeah, let me introduce the speaker for today. So we have Vindhya Gunawardana, who is an associate technical architect at 99X with over 10 years of experience in the IT industry. Vindhya is an AWS certified solutions architect who has been involved in designing and developing various software solutions throughout her career. So without wasting too much of a time, I warmly welcome Vindhya to take over the screen and go ahead with the session. Vindhya, over to you.
Thank you, Ishrat, for the intro. Let's get started with today's session then. Today we are going to look at serverless. If we'll first look at what is serverless and some principles with serverless, and then we can talk about some serverless offerings with AWS, and then finally we can move on to talk about some use cases and some sample architectures with AWS. So if you look at what is serverless, does that mean like we don't have servers? It's not actually. Serverless doesn't mean that there are no servers. In fact, there are servers. It's just that you are not managing them. Suppose you have a web application that you need to host, and you might decide to host it on-prem in case you have, a data center on your own, or you might, decide to choose a cloud vendor, create a VM, and host it there. Whatever the case, you're still going to be managing the service, because I mean you are going to apply patches and maintaining them. You are going to configure backup security. Have to think about scaling, availability, even like with AWS, we have EC2 servers. So even with that, you'll realize a little while like you are the one who is managing them. And this is where actually serverless comes to rescue. With serverless, all these nitty-gritty tasks, these repetitive tasks, you can abstract them away, and you can focus on the business logic and developing your application. So if we look at the basic principles with serverless, as I mentioned before, the first one is like you're not uh, provisioning or managing the service. With serverless, you have some building blocks, and what you are doing is you are like using these building blocks in building the applications. With some examples, you'll realize what are these building blocks are. So for now, let's move on. The other most important principle is you pay only for the usage. Suppose you have a serverless function that runs for just 10 milliseconds, then you will only pay for that 10 milliseconds. And most importantly, you will don't have to worry about scaling and availability, because it will automatically scales with usage, and it has built-in availability and fault tolerance aspects as well. So we looked at the basic principles with serverless, and if you look into the various serverless offerings. You might heard that serverless. It started with functions. Initially we had Lambda functions with AWS, and those days we even used to refer to them as function as a service because they were only like those compute functions. But today, as of today, like the serverless landscape, it's very big. You have uh, serverless offerings in various compute and data storage, and messaging, application integration, big data analytics. It's a very big landscape. And if you look at the serverless market offerings, that's there actually almost all the big cloud vendors are now into serverless, not only Amazon. So, for example, if we take the famous Lambda, the event-driven serverless compute platform, even with other cloud providers, you have synonymous offerings. With Azure, you have Azure Functions. With GCP, the Google Cloud, we have Cloud Functions. With Alibaba Cloud, we have Function Compute. Likewise, there are a lot of market offerings. But today, our focus is actually towards AWS. So let's just look into the serverless offerings with AWS. So with AWS, as for serverless compute, we all know we have Lambda, and then we also have Fargate. With Fargate, actually what we do is we can the containerization is now popular. So with Fargate you can deploy containers without managing the infrastructure. And when it comes to data storage, we have S3. It's actually object-based storage. It's very cheap, and you can even configure S3 as a to host a static website. That's very useful. And then we have DynamoDB. It's a serverless NoSQL database. And then we have Amazon Aurora Serverless. Aurora, it's Amazon's proprietary database. It also has this serverless offering. And then when it comes to application integrations, we have EventBridge. EventBridge, it's a serverless sort of an serverless event bus, which you can use for these integrations. And then we have step functions. With step function, I mean, with if you have to manage a serverless workflow with the different steps, you can use these AWS step functions. We'll be looking at AWS step functions in a bit in a use case. And then when it comes to messaging, we have SNS, notification service, and then SQS, it's a queue service. And and then when it comes to API management, we have API gateway. It's mainly used in managing REST APIs, HTTP APIs. You can even use it for this WebSocket APIs also. And this AppSync, it's mainly used for GraphQL APIs in developing and managing GraphQL APIs, all of them in a serverless manner. And in data streaming and analytics, like in 2021 reinvent last year, like they had some new offerings with regard to these ones, most of them, these four. Like, so with Kinesis data streams, it's Kinesis data streams, it's actually used for stream ingestion. When you have a continuous sequence of data flow into a system stream, in injecting it, so you have the on demand option now, so you don't have to provision capacity. And then with then we have EMR, when you want to work with a big data workloads with with like Apache, Hadoop, Spark. We all have the serverless option with that now. And with Redshift, it's if you like working with data warehousing, so now you have a serverless option. And even with this managed Apache Kafka service that we have with AWS, it also has the serverless option now. And there are like some more. So these are the basic ones I thought you might know. So with that, we can look into some use cases and sample applications. The If you look at the main use case with serverless, any application where you have an uncertain or an unpredictable usage pattern, you can use these serverless offerings. For an example, if you have developed this new website or this mobile application or this new and you want to host it, so you don't know how the demand pattern would be, you don't know how the traffic would be, so you can uh, start by deploying it in in some of these using these serverless offerings, because you don't need to know how the usage pattern would be with serverless, because you pay only for the usage and it scales automatically, and the availability also being handled, so it's very beneficial. And when you want to do something upon an event with event driven data processing, and you want to manage streams, and even with bots, we have conversational bots. Those are these small chat boxes you see, sometimes when you go to a website, you see some uh, pop-up chat saying, how can they help you, sort of. And then service bots, you might see like in Slack or somewhere, like when you like paste a URL and it retrieves some additional information and show it to you, things like that. So those kind of uh, ad hoc uh, tasks you can easily use serverless. um, if your traffic is like very high, then actually you'll of course have to pay more. And if it's predictable, I just wanted to mention, like, cost wise, there might not be much of an advantage in using serverless, but of course still you'll have this advantage of being able to get rid of managing servers. That advantage is still there, but that's something you should actually think about in applying serverless. Um, so with that, we'll first discuss about a serverless web application. Suppose the web application that you needed to host, it's a static web application, a single web application developed using maybe Angular, Vue, React, sort of, and you need it to be scalable, available, and need to be secure, of course. So how would you develop it? If we first look at the traditional way, the serverful way of doing it, I'll have a look at that just for this one, because then you will realize the advantage of serverless architecture. So of course, you might go for an EC2 server, and the front end application you might host in an EC2 server, which is in a public subnet, and the API, it's in another EC2 server. With the data store, I'm using, say, a relational database, which is in a private subnet. And you can easily host this, and users can use your website now. But uh, with this, we don't have scaling. If your website becomes popular and more and more users uh, try to access it, you need to add scaling. So if you have to add scaling, you might obviously go for an auto scaling group, and then you might decide to have a load balancer for the both front end and back end. And to scale the data storage, you might decide to introduce a read replica, so that you can uh, offload the read load. So now we have auto scaling in place, but this doesn't have a high availability. This availability zone one goes down, your application will not be available and the users will not be happy. So if you wanted to add uh, add high availability, you will go for, like, more than one availability zone. The auto scaling would scale would span across multiple ACs, and the load balancer, you will choose a multi-AC load balancer. And with the RDS, you can go for a multi-AC RDS instance. So you can see, like, how complicated this got. And this is just within a single region. If you want, you can have the same setup in a different region, and balance the load across the regions as well. So, so this is the traditional way. If you look at how can we develop this using these serverless building blocks. So if we look into these serverless offerings, so where are the serverless offerings? Yeah. Okay, so we have, I mentioned like we can use S3 to host a static, I mean, we can configure S3 so that it can host a static website. So we have a single page application. It's static website. So we can use S3 simply for that. And for the data store, we can go for a DynamoDB. And of course, for compute, maybe you can go for a Lambda. And then we'll go with the simple API gateway. We are like, say, we are exposing a simple REST API. So these are the building blocks, and we have wired it up. So the static context goes to the S3 bucket, which is configured to host the static website. And then we have the REST API calling to the Lambda function, and then it's calling to our data store. Now you might wonder, like, how can we incorporate availability and, scalability? Because even in the traditional architecture, the initial architecture looked simple, right? And it would complicate it with all these other things. But here, the interesting thing is you don't. This would be the final architecture because you don't have to worry about scaling. It will scale automatically. You don't have to worry about availability. This would be fault tolerant and highly available. All these components. So so that's the main advantage. One of the main advantages, I would say. Uh, and continuing with this, like if we wanted our users maybe to say this is an e-com application, so you want users to sign up, and purchase, so you need a security, you need authentication and authorization. So you can use something like Cognito. It integrates well with these serverless components. And then, like if we want say global presence, you want your website to be global, so users across the globe is now accessing your website. So you have hosted your S3 bucket, say in Asia, so you have, say, a European user trying to connect it. So there'll be a very big latency because it has to, like, travel all the way for every request. So for that, we can actually even use CloudFront. You must have heard CloudFront. With CloudFront, actually, I mean, across the globe, we have different edge locations and different edge location caches. So if we enable CloudFront, then the users would be connecting to the nearest edge location. And if they request a particular resource, image file, a video, or HTML file, then if it's not there in this cache, first time it will retrieve it using this bucket and then cache it, and will uh, return it back to the user. So from the next time a user in this area connect to the same each location, you don't have to travel all this way to get that file. It's there. But so that's why it's important. But with CloudFront, there's some additional cost involved also. You might want to think about that. And so architecture wise, like, then it would look like this with all these new features. You have a CloudFront global distribution, and for in order to I know, with for security purpose, you can even use this origin access identity here, like prevent people from directly accessing S3 bucket. And the data store, since you're like going global, you can even go for DynamoDB global tables. With DynamoDB global tables, they have automatic replication of data from one region to another. It's very easy. So now with this, we have this kind of architecture is suited, like so now we have this your static web application, secure, highly available, fault tolerant, and secure and global and everything. So That the first use case I wanted to discuss. This is a very famous use case with the serverless. With when we are working with Lambda, one of the things I didn't mention, but you'll learn a lot of about Lambda in the upcoming sessions we have. So with Lambda, we usually create one Lambda function for one purpose. I mean, we usually follow the single responsibility principle. So with a normal web application, you will not just have one Lambda function. You will have multiple Lambda functions. Um, so say in this same example, if we continue with this example of having this e-com website, if a particular customer searches for a product, you will not just search for the product, right? So you might not just query the product database. You might query the prices. You might check stocks, the stock availability. You might need to do some aggregations, computations. So there's a workflow involved with such complicated tasks. So then ideally in the design, following the single responsibility principle, we'll have, if we have Lambda functions, then of course we'll have one Lambda function for loading the product, one for pricing, one for stocks. Likewise, we will have multiple Lambda functions working parallelly or in sequence. So there are workflows. How to manage this kind of workflows? For that, actually, there's an interesting offering with the AWS. We have step functions. With a step function, I mean, it's a sort of a state machine where each state is a step, so you can have a track of which step are you in, which one failed, which one was a success. You can uh, keep track of the workflow. It's a very useful. If we look at the architecture point of view, so you might not have a Lambda function. When you have complicated, you might have some sort of step function workflow. And it's just not Lambda. I mean, it integrates with many AWS services, this SNS, SQS, API Gateway, Fargate, DynamoDB. Actually, you can refer the AWS documentation for the full list of uh, services. So that's the second use case I want to discuss. And as for the third use case, I wanted to look at some event data processing. Suppose now you're the e-com application, you want to improve the online shopping experience to your customers. So you want to add these product images and product explainer videos, and the administrators may be uploading these videos and images. And once they're uploaded, you need to create a thumbnail of it and show it uh, in the initial screens. So how do you do that? So when you say you upload image, you upload a video, it's a particular event. All you need to is a triggering function to do something when this event happens. So if you look at creating a thumbnail, of course, an administrator uploads a image file to S3 bucket. You can configure it to trigger a Lambda function, and create a thumbnail out of it and store it maybe in a different S3 bucket or in the same S3 bucket. um, so you can go for a simple architecture like this. But when it comes to a video, creating a video thumbnail, when you need to process videos, a Lambda function might not be enough, because um, with Lambda, actually, usually it's short lived. Usually you don't do anything you can't do anything that's more than 15 minutes. So with when you need to process videos, maybe you can launch a Fargate task. I think this is also serverless compute, so you can you can run serverless containers. So it will do this video processing in this container, and then create the thumbnail, or maybe just create a low resolution out of it, and put it into S3 bucket. So that's about event processing. And then if we talk about stream processing. So streams, as I mentioned, it's so you have continuous flow of small chunks of data. So that's a stream. So say if we try to plug a use case to this same scenario we have been building on. Say you want to now you want to analyze and identify the application Intel. So for that, you might need to analyze these logs, these click streams, a lot of things. So how can we process this kind of data? For that, actually, we can use these Kinesis services. So get when we get this when we get this stream data, it get injected. We can use Kinesis data streams to inject these stream data, and then you can use data firehose to you move these data streams to a data storage. So the raw events, maybe we can put it to an S3 bucket so that you can later analyze it. And you can use Kinesis data analytics. You can data analytics and do some real time analysis, derive some information, and this process data, even if you want, you can store it in a different S3 bucket. And these derived values, these insights, you can process it using lambda function and store it in a DynamoDB table. When we have these these derived information, these aggregated results, whatever, in DynamoDB, you can easily access it via the web app. So this is like, there are various use cases with using streams and data processing. This is just one basic use case. So that's mainly the use cases I had. And uh, when learning more about serverless, I wanted to discuss. So we have this. You can of course refer to the AWS Serverless documentation, and they actually, you have getting started. You have all these information. So here, like, you have a lot of development frameworks also. So this serverless application model, SAM, it's very useful. It's actually a template. If you have heard of uh, cloud cloud formation templates, it's infrastructure as code. As you have versioning with source code, you can it's infrastructure as code. You can version, you can manage the infrastructure. So this is very useful. I'll And then we have AWS CDK, serverless frameworks, and a lot. So you can go through this. And especially, like, since this is a getting started session, I thought of showing you this serverless land.com. Also, this is also managed by AWS, where you can find a lot of blogs, videos, and more importantly, what I wanted to show you is these different patterns. So I wanted to, like, say I will use SAM for the as the development framework. Maybe you're using, say, Node.js, and if we, like, go for a very simple say you want Lambda and maybe DynamoDB. So DynamoDB to Lambda, invoke a Lambda function from changes to DynamoDB table. So if you you can go into this, and say you can see what it does. It deploys a Lambda function, a DynamoDB table, and any IAM resources that's required to run the application. And then when your, like, items are written to database, it will trigger the Lambda function. It's event driven. So so if you want to get started, we have there's a Git repo, and actually this I have checked it out. So let me quickly show how easy it is uh, for newbies. And for that, actually, you have to install. I have installed SAM CLI also, serverless application model. So So let me go to this one. Okay, it's there. And how to deploy. Before that, let me show you. So if you look at Lambda, I mean US is 2. There's only one function. And if you look at go to DynamoDB, you don't have any tables at the moment. So let me deploy this. So it has a name. So I'll US is 2, confirm changes, no, allow, yes, disable rollback, no, go with the default. So it's it will automatically configure. We have this stack. This is a small one, so it shouldn't take much. See, it adds a DynamoDB table. So we are going to add these resources, a DynamoDB table, IAM role, Lambda function. So it's being created. Yes, so it's successfully created. So if I go and refresh, now we have a new table created. And if we go to Lambda, we have this new Lambda function. So it already has a trigger, the DynamoDB trigger. So so here you can have triggers and destinations and everything. And if we go to cloud formation, there's let me figure out my one only. So you have this SAM app. It was earlier. Yeah. So this is the cloud formation template. So you have all the resources that it provisioned. So let's see how it works, whether it works actually. Let's go to the DynamoDB table, explore items. There are no items as of now. So let's create item. I just added just one value to the single column, just this primary column. So what I wanted to show is whether we are going to try to see is whether this triggering part works, right? So if you go to monitor, so this, even though I didn't mention like this integrates well with, CloudWatch and, X-Ray, that sort of thing. So let's see whether we can check this. So if you look at the code here in the Lambda function, you can see that what we are doing, it's just we are getting an event, we are just logging it. So you can, this logic, it can be you can, add it here, you can upload a zip, or now you can even have a container image with ECS and configure Lambda to, get that image out of ECS, Elastic Container Service. So it's there are a lot of various uh, you know options that's there for you now. So if you look at CloudWatch, now a new log stream has automatically been created. We have a log stream, and see, we have this event log. See, you can see the one value, it's there. So so we have so it works. So you can see like I mean, you can like with these cloud templates, sorry about the SAM, with SAM templates we can, easily get started with these things. So I just wanted to show you that. And That's mainly what I uh, planned for to discuss. I thought of leaving out a couple of minutes if you had any questions. Uh, any questions? Ishrat, do we have any
Yeah.
questions in the channel?
So far I don't see any.
Okay.
So yeah, guys, if you have any questions, y'all can drop it on the YouTube live chat, and we can answer them right now.
Yes, so I was not looking for looking to give a very deep understanding in a single service because it's not possible within that kind of limit. So that's why we have all these subsequent sessions planned, so you can get deep into the. I hope you got something an understanding on serverless. Uh,
Yeah, guys. So if you want to know anything about AWS serverless in general or any of the basic concepts of cloud computing, even you can drop them in the chat, and we'll be happy to answer them.
yeah. Okay.
Yeah, we can
Seems
wait
not.
for a couple of minutes and we can wrap it up.
Seems not right.
Yeah, I think we can go ahead and wrap things up. So yeah, I'm sure most of y'all must have learned something new today and got a good understanding of the basics of like AWS serverless computing, because I certainly did. So I think you all also must have learned a lot today. So now to wrap things off, I would like to take the time to thank Vindhya for accepting our invitation and taking a bit of time from her busy schedule and sharing her knowledge with all of us. So the next webinar in this series will be happening in a couple of weeks, and it will be regarding AWS compute services. And I hope to see you all there as well. And also, like, don't forget to keep in touch with our social media platforms for the registration links regarding the upcoming sessions as well. So do subscribe to our YouTube channel and follow us on the social media platforms to stay up to date. So I think we are good to wrap things up.
Yep.
Yeah.
Okay.
So
Thank you.
thank you all for joining and take care.